I'm going to try to explain time with a yo-yo. First, let's pretend that dice is the universe, and it's either expanding or contracting. Ultimately, we don't know, but what we do know is that there's a form of scalability to it. If I take my relation of time in a line, this represents the future, and this represents the past. So you essentially have points of now that are ever scaling in different directions. And every moment in between is the progression of everything that is existing at this very moment. But the problem is, this only applies for scalability. So fluctuation and scalability in this line of perception, or time, is essentially what time is. It's like if I map out the entire universe in a grid and have it fluctuate, like you're fluctuating bigger and then smaller and then bigger and then smaller, and then eventually you're somewhere over here. If I were to change one thing at all, it would change the entire aspect of time itself. So it would just find ways to find itself. So essentially that's the mass, and it fluctuates depending on the point of fluctuation that it's in. That scalability is time. Let's pretend that's the ocean and I froze it for a second. I could predict from that one slice of data what the rest of the ocean looks like. But every second afterwards, I can't necessarily tell you what happens because of probability. It may not be an absolutely big number of different probabilities, but there's always a sliver of a chance that something crazy could happen within the next second. This is primarily why I refuse to play within confines of old perceptions of time. It doesn't make sense to me. Because if it's the scalability aspect of time, if you change one thing at this point, it will change everything about this point. So yes, if you were to completely remove yourself from this point in time and bring yourself back to this point in time, you would essentially change the entire string. It's no longer the same string because that portion of the geometry in this time has disappeared and is replaced in this point in time. I suppose that's why it wouldn't be a good idea to meet yourself. But yes, that's essentially what time is. Time is scalability of mass through measurement and increments. But if everything is a consistent moment of now, does it really exist? No, time doesn't really exist. But you're left with topological scaling of what is at the moment. And if you change the topological scaling, it somehow destroys everything.